So this is your first PowerPoint looking at river features in the hydrosphere topic. And there are 4 features, each in the exam under the new marking instructions are worth 8 marks per feature. You can see from these instructions here that you get a maximum of 4 marks for actually describing and explaining the processes, 2 marks for each developed process. So we'll look at those. It's a bit like the processes we've already looked at when we're looking at coasts. So it's the same idea in terms of how the marks are allocated for processes. So a mark for a named process should only be awarded if the candidate develops it in some way, i.e. you attach it to where it takes place, that erosion, or how it works, or what it does to change the feature shape. You get a maximum of 1 mark for a list of unexplained processes. So lists or names of processes on their own can get you 1 mark, with at least 2 processes is required for 1 mark. So potentially you could pick up 2 marks for a list of 4 processes. Examples of features, i.e. their names, are good practice, but they're not guaranteed to collect you marks, unlike the coasts and glaciation features of erosion questions that you can pick up higher. So they're good practice to stick them in. It's easy to do. Just write down e.g. I'll put the name of one down if you've got one, but we'll probably not pick you up marks, but you might be lucky. Right, you're going to go over the processes in this presentation. You should know these really well. If you, as I said, if you explain these in detail, you can pick up 4 marks out of 8 just for talking about 2 of them. So with rivers, these are all processes of erosion that you can pick up marks for. The first one is hydraulic action, and that is the sheer power of the water smashing into something. And what it does is it compresses air into the riverbank, and it causes materials to be dislodged. So the wording is quite specific. So causing materials to be dislodged is kind of key, and that air forced into cracks or into the riverbank is also key to explain how hydraulic action works. Now you'd apply this to a specific feature. So if you remember from National 5, a meander is a bend. So on the outside of the bend, the hydraulic action is taking place as the water drives into the outside part of the bend, and that forces the air in and makes the material become dislodged. So that explains how it works, where it works, how does it change the feature shape? Well, a meander moves, and it makes that meander kind of deepen and go further out. Okay, and they migrate downstream over time. That would be the how it works, the where it works, and how it changes the shape of the feature. So that's one example. So abrasion, you will come across abrasion again when we look at glaciation, and we've already talked about it at coast, so it's the same idea. Remember, abrasion is also known as corrasion with an A. So abrasion is the force of the water throwing bed load, and what I mean by bed load is material that rolls along the bottom of the bed of the river, or is held within the water, or is bouncing along the bottom of the river. We call that saltation when it's bouncing, and that would be thrown against the riverbank, and that causes material to be thrown away. So if you picture someone holding a baseball and actually tossing it, throwing it at a riverbank, we have that idea, but there'll be the water that's carried the ball or the stone in this case, and it made it strike the edge of the bank, and it causes bits to rub off. And if you wanted to give it an analogy, it acts like sandpaper. So the material within the water is rubbing against the edge of it, so it'd be like sandpaper in techie. And really, when we look at glaciation, abrasion is about sandpaper action, much more than it is about being thrown against the edge of something. Solution, this is quite straightforward. It's literally when soluble rocks or the river bank effectively acts with acids in the water and they cause it to dissolve. Okay, so that's solution. That would give you a mark 2. The last one there we have covered before on coast is differential erosion. This particularly would be talked about when you're talking about a waterfall formation. That's where you bring this one in. It takes place over bands of more and less resistant rock, where harder rock is overlaying softer rock in place. Softer rock erodes more quickly. That would be a key bit. So the softer rock erodes more quickly than the harder rock, and you've got these bands of hard and soft rock. So you've got 2 videos to watch within the presentation, so that is one of your tasks. So I want you to go away after you've watched this Loom presentation, open the PowerPoint and you click on these videos. I just want you to watch them. One from Time from Geography about erosion processes that we've covered, shows you a bit more of the action of them actually working, and the other one's about transportation processes. So it's the idea, though we don't cover it too much here, I'm focusing on the chronology you need, but the river will transport material down from the mountains, and gradually our mountains are shrinking in size partly, and materials taken away from them by rivers. They're kind of a conveyor belt of material, so they'll take fine grained material, silt. You can see in a river when it's flooded it goes brown, so it's carried in suspension. They can carry material by bouncing along the riverbed, that's called siltation, or as bed load, it might roll along the actual bed, called traction. There's another method as well, but that video will tell you a little bit about those processes, which is quite a good bit of understanding about how rivers transport material. And obviously they can drop it off. There are deposition sort of processes. We're not going to worry about those too much here. Effectively what happens is when the water moves more slowly, it has less energy. And if it has less energy, the material that the water's carrying will be dropped out of it. And that's when we get deposition happening. And we do talk about that a bit when we look at meanders. So I'll move on. And today's video is going to be, or this video is really focusing on the formation of a waterfall. You've got a video to watch here. So again, you can start off your notes. You're going to have, effectively after this video, you're going to take a note on the formation of a waterfall. You're going to note down some diagrams and some labels around. You're going to copy those off the slide, and that will give you effectively everything you need. So you don't need to take any notes from the film. This film is based off a Time for Geography video, and it shows you how a waterfall's formed. The other video under here is done by another teacher who teaches GCSE, so it's kind of like National 5s. It's not quite necessarily the level you need, but it's really good to consolidate your knowledge and understanding. So there's two little videos to go and watch about the formation of a waterfall to get your understanding in, and then I want you to copy down the following slides. I'll just quickly talk through them. There's another extra video there actually about drones from looking at waterfalls, so that's optional. You don't have to watch that if you really don't want to. Right, just remember all these 4 features. I've put this box in at the top. Remember, talk about processes. Key ones that you'll be talking about: hydraulic action and abrasion, and you can get 4 marks for those, and that's your maximum 4 marks for processes for every question. So learn those: how they work, where they work or change the feature, and how they change the feature shape. I want you to copy these diagrams that I've drawn on many whiteboards, as you can see, and I've added some labels to them, and that's how I want you to present your answer. So the key points here, I would start off with here: 8 marks, remember. River flows over bands of rock, which are hard rock on top and soft rock underneath. Okay, 1 mark. The softer rock is eroded more quickly than the harder rock. 2 marks. This is called differential erosion, and I might move this down if I can. You can cross it out. There we go. This process is called differential erosion. That gets a mark too, so that's 3 marks. Hydraulic action, 1 mark. Helps form or create the plunge pool. So that's this area here, which is a bit deeper. This is the plunge pool. Okay. What does it do? How does it change the feature shape? It deepens and it widens it. It's the shear force of the water smashing into the riverbank or the bed, and compresses air into the riverbed, causing materials to be dislodged. So that's getting me my 2 marks for my process. Diagram 2, you can see, is a bit different. What's happened is the old position of the rock sticking out is in the dotted line here. We've still got hard rock and soft rock. This area here shows undercutting. So this hard rock's been undercut. We've got another process to talk about here. So I'll also note you're going to have more labels around this specific diagram. So the next slide is diagram 3, which is the same diagram with different notes around it. So leave some space around your page for when you're taking your notes. So abrasion. This takes place and causes further widening and deepening of the plunge pool, and it increases undercutting. So this is where it works. I haven't explained how it works. So how does it work? In high flows, the water, in other words floods, the water in the plunge pool, there's more of it kind of coming over the edge, it swirls around like a washing machine. And what that does is it throws rocks against the soft rock. So you can imagine my cursor going and smashing into this soft rock here. Okay, and by doing that, it's causing a rubbing or sandpaper sort of action against the side and causing that widening and deepening. You also get attrition. Attrition is effectively, if you took your hands as 2 fists and you had your pointy knuckles towards each other and you bounced them off each other, which I'm doing now, as you can probably hear. If you kept doing that over hundreds of years, your rocks would become rounder instead of being angular or have little sharp edges. So they'd be quite round. And what were actually happening is, as well as bouncing off each other, that attrition, it can bounce off the edge of the plunge pool or roll along it, and that actually can cause some further widening and deepening of the plunge pool. But remember, you're only going to get 4 marks of processes, so you wouldn't necessarily need to discuss this. You just hydraulic action and abrasion for a waterfall would be enough. Other marks for a waterfall, remember, this is your last slide on a waterfall. So it's the same diagram, different annotations. So what does this arrow mean? This is to remind you, this is why I want you to draw a diagram, because these will give you clues or things to remember to do. You've got this section here, dotted line, and this arrow, and it's reminding you that over time these processes, particularly the hydraulic action and abrasion, keep happening. They repeat, or they continue, and they cause the waterfall to retreat upstream. So that's what the arrow is reminding you, and that creates a steep-sided gorge, as you'll have seen in the video. So that's really giving you another 2 marks, just really talking about that the repeated action of these processes causes the waterfall to go back upstream, creating a steep-sided gorge, 2 marks. The undercutting we've talked about causes an overhang of hard rock. Just mentioning that overhang like this can give you a mark. Over time, the overhang becomes unsupported and it collapses. You can see that's this arrow here labelled, and these bits of rock into the plunge pool. Those rocks, they add material into the plunge pool that help the attrition and abrasion take place and cause that deepening. Your example, if you want to remember it, it's a nice one to go and visit if you get the chance. It's up near Inverness. I took some hires here a few years ago. So an example of a waterfall is Corrie Shallach in the Highlands, and you can go on a big suspension bridge and go over the huge gorge, and then you can walk along the walkway next to the cliffs and go to a viewing platform and see it. But I'd recommend going up there and having a look if you get the chance someday. A nice part of the world to have a look at. And that's the end of your presentation for today. So go away, have a look at the activities on Google Classroom, take your notes, watch your videos, and submit me a photograph of your completed diagram with notes around it for today, please.